Have you ever looked at an aircraft wiring diagram and felt completely overwhelmed? Well, you're definitely not alone. In this video, I'm going to show you how to read aviation electrical diagrams from a beginner's perspective. We're going to walk through three real examples: a comm radio connected to an external comm radio, a radio wired to headset jacks, and a weight on ground switch from a helicopter. And by the end, you'll know how to follow a circuit and understand what you're actually looking at. Let's get into it. All right, so this is our first example. This is a Garmin GTR 205 wired up to an external comm radio. We're just going to keep it simple. Here, this is the audio out high, or we're talking about the audios here about the radio going to the audios of the external radio. So they're pretty one-to-one for the wiring outputs. So you just want to take it slow, going from left to right. Just read slowly what you're going through. You can see here on the left side, it's comm audio out high, external comm key out, comm audio out low, some aux audios and some aux audios. On the other side of the comm radio, you see the same thing. So whenever you're looking at these diagrams, you want to look for these pairs of comm audio outs and comm audio, low inputs. See how the output of the Garmin goes to the input of the external radio. So that's just the pair, because the output of the GTR is going to the input of the external radio. So if we're looking here at the GTR, the output is pin 16, and that's going to be going all the way to whatever COM1 mic 1 is. On the external radio, pin 54 goes to the mic key, and pin 37 goes to the audio low. So when you think of this, the audio outs need a high. That's kind of like your power in, and they also need a low, which is your return. So it's kind of like a circuit, kind of like this, kind of like that. So they need to transfer this audio information together, back and forth in a circuit. Now the external comm key out, that triggers the radio to start transmitting your voice. So it's just a switch, no like return or ground for that, just something to let the circuit know that, hey, we want to transmit now. And if you look at the diagram further, we can see these things right here, and right here. These are representations of shielded wire. So shielded wire helps prevent static in your headset whenever you're speaking or listening. So these are three wires in a bundle protected by a shielded layer. Now, what the diagram is telling us, you see this little triangle here, that shield is grounded towards the back of the assembly of the GTR. That's where it's grounded. You can see that the other end is floating. We don't ground that end because that end is just going to be free floating, and if we were to ground it, there's a possibility we could get a ground loop and then our audio could be a little bit distorted. So what Garmin is telling us here is that on one side, or the GTR side of the shielded ground, or the shielded braided wire, we're going to ground that to the back shell of the GTR 5. So that's pretty simple. Just a basic one-on-one transfer of the wires, nothing in between, no circuit breakers. If you're going to the aux ins, again, you can see the highs going to the highs, and then the lows going with the lows to complete that loop. Not a circuit, more like a loop. Same thing with the aux 2s. So that's the first example. Pretty easy to follow. We're going to get a little bit more in-depth with some of the later ones, but they're still going to be pretty easy. Okay, this is our second example. This is a GTR 205, and these are the audio outputs for your headset jacks and your mic jacks. So we just got to read it slowly and understand what we're looking at. So here in this section, you're getting headset 1. This section, headset 2, headsets 3 and 4. So this is making me think that this is the pilot. Headsets 1 is the pilot. Headsets 2 is co-pilot. 3 and 4 are the passengers. So we can take note of that. And if we look further, look, we see a pilot push to talk and co-pilot push to talk. So if you keep going, mic 3 right here, passenger mic, and then mic 4, your other passenger mic. And if you think about the airplane like in your Cessnas, you see that they have 2 pilots, co-pilot and the main pilot, and then 2 seats in the back for the passengers. And it's giving us the outputs for that. So if we look up here by headset 1, see audio out left. So that's the left side of your headset, and then the audio for the right side of your headset. And it explains what pin to take that to, which would be 10 for that right, and then 51 for the left. And then you can see your audio out lows. Remember how in our last example we had a high and a low? These are the highs essentially, the audio out left and the audio out right, but that signal needs to travel back somewhere, and it's going to travel through the audio out low through pin 31 and do a full return. So that's how you're getting your audio. And if we look further, you can see these little chevrons and a rectangle and a number 1, and then same thing that we saw last time, the little loops with the terminations on the bottom. So this indicates a headset jack. If you look inside a headset jack in aviation, you'll see kind of like prongs, kind of like what you're seeing here. And each one of those prongs hits a different point in your jack. Well, or the plug, I should say, the plug, and they're each responsible for doing these certain things like your audio left and right and audio low. So that's just the diagram here. Same thing for the co-pilot and same thing for the passengers, but you can see if we go to the passengers, we see that they combine them for 3 and 4 for the passengers. They split off, they put them in parallel. You can see that. So what's happening is that no matter what, 3 and 4 are always going to share the audio. So if you follow here, come down here, that shares, and that shares. So 3 and 4 are going to listen and hear what's on the left side and also what's on the right side of the audio out. Let me make this a little smaller. And I'll change my color right here. And that dot means that those wires are connected. Come out here, and then the low's back. Yeah, and all the returns are back. Sorry for the messiness. But look again, you were using shielded wire to help prevent that buzzing or static or headset noise that you're hearing if you've heard it before on kind of older systems. And again, it's telling us to put that shield and terminate it at the back shell of the Garmin to help prevent that. You can see the other side of the braided wires are just floating. So they're just terminated. They don't go anywhere. They're just sealed up. But the other side gets terminated at the back shell. We're going to our mics. Comm 1, mic key. Comm 1, mic audio in high. Comm mic audio in low. So this is going to be covering the pilot push to talk, and see how it has a little diamond and a 1 or triangle. All headset and microphone plugs must be electrically isolated from ground. So if you're looking, well, this is a physical installation, but you never want any of these points to be touching the airframe. You want them to all be floating. And we do that by using washers and a washer stack. So comm 1 mic key high, again earlier, that triggers the radio to start transmitting your voice. So if you follow it, here's kind of like the high side. It's going to follow around. It's going to stop here. It's going to wait for you to push your button on your yoke or your cyclic, and it's waiting for you to push it in so it can find its return back into the low in order to start transmitting. For the mic audio 1 in, see it's coming out through 19. Just stay in there. Just stay in there until you plug in your headset, and then it'll have a return path to the audio in low. Wherever you see audio in highs, there must be an audio in low, and they must kind of form a loop back with each other in order to work. Same thing with the co-pilot, but if we go to the passengers here, these are the mics for the passenger and the other passenger. So it's just a simple circuit loop. The audio in high goes into your mic jack, and they probably have their own push-to-talk handheld somewhere, and then that goes and returns back to the audio in low. It comes back here, returns back to the radio, and then you can hear everybody within the cabin. So it's pretty simple. There's always return paths with these. With audio, there's always a high and a low in power side. So that was just an example with audio. The next example we're going to do is the weight on ground Hobbs meter activation circuit. So this is a helicopter circuit. Here's the weight on ground switch right here, or the diagram I mean. And we want the Hobbs to start counting whenever the helicopter is in flight and the weight on ground switch is released. So this is the main thing we want to make sure we're working with. If we look here closely, there's a positive and a negative side. So we know that this counter needs power from somewhere. This diagram makes it easy that there's a plus side right there. So we must know that it's getting power from somewhere, but we don't know where. So let's follow it. We're going to follow the plus sign, come down, and here. You might be thinking, okay, what is this block? This is just a block with multiple connection points. So T, W, Y, and Z are all connected together with the lines. So anything that shares T, Y, or Z, or W is going to get power also. So let's continue down the line. We know that T is the source. We're going to follow it up. We're going to follow it up. We're going to follow it up. Then we get to another terminal block. Looks like I can't read that. T, A, Z, and Y. Same thing. They're all connected together, so they must be getting power from somewhere. Looks like they could be getting power from multiple areas. It could be from the line contactor here, or maybe the solenoid. Most likely the solenoid, because the solenoid needs power in order to activate the line nav contactor. So this is probably getting power from somewhere else. So let's just assume the power is getting from the aft line contactor. So come up this way, hit the terminal block, come this way, come up and over. Now you're on the positive side of your Hobbs. But your Hobbs needs a negative. It needs a ground to go to somewhere, or else it can't start counting. All right, so the Hobbs makes it easy. It tells us where the negative is. So let's go this way, follow it down. We know it needs to end somewhere. It needs to end either at the battery or airframe. Follow it down. Oh, look, another terminal block. And these are all connected. And if we keep going, we run into an override weight on ground switch. Okay. So that's not going to go anywhere. So let's just ignore that for right now because we don't want to override anything. So we'll take the other direction and we'll come this way, down and over to the right. And we actually end up on the weight on ground switch, which is good because that's what we need to see. So as you can see, the weight on ground switch is open. The electricity can't go anywhere. That's because the helicopter is in a state that it's on the ground right now. So the switch is currently in ground mode. If it were in flight mode, this switch would trigger down. The electricity would travel out to the right and end up at E44. E44 is ground somewhere. It probably goes to another terminal block or either goes to a lug somewhere on the airframe, but it eventually goes to ground. And that's the circuit for the Hobbs meter, weight on ground switch. So if you're getting any issues, just know that there's a weight on ground switch there. Let's say, for example, We hit the override switch, the override wait on ground switch in the co-pilot's floor panel, just on accident. Let's see what that would do. So that would trigger this switch to go down this way. And that would also trigger this to go to ground, wherever that is. Because it's going to go somewhere. It's either going to go hit the override switch and start counting, or it's going to trigger whenever you go into flight and find ground through E44. So this is just a little beginner level of reading electrical diagrams. You get more proficient the more you're reading at them, but let me know how you guys do it. I'll let you know if you're interested. Let me know if you want an intermediate level. We'll walk through that. And if you like this video, give it a like and subscribe. And that's it for right now.